All right, we're going to talk about probability now. We have two different types of probability that we're going to talk about. We're going to talk about experimental probability, and we're going to talk about theoretical probability. So there is a slight difference in them. Experimental probability is the probability event equals the number of times the event occurs over the number of trials. Okay? So this is very dependent on the actual experiment. So if you're flipping a coin, if you flip a coin and we get a head on the first one, now we have a experimental probability of a heads as 100%. And so every time you flip it, you would recalculate that probability. Okay? So theoretical probability is the total number of successes over the total number. So in a coin, we have heads and tails. So our theoretical probability of a head would be 1/2. Okay? Here, my experimental would be 100%. Okay? So they can differ. Now, ideally, what will happen is eventually these will come to the same value. If we do the experiment enough times, it should match up with our theoretical. So we're going to look at kind of a normal six-sided die. So if I look at rolling, let's say I have rolling a 5 on a standard die. Well, how many 5s are there on a die? Well, there's only one 5 on the die. Okay? So there's 1 5. And then how many numbers total are there? Well, there's 6 total numbers. So our probability, our theoretical probability of a 5 would be 1 out of 6. So that's our probability for rolling a 5, is 1 out of 6. Let's say I wanted to know the probability of rolling an even number. So I would kind of find out how many even numbers there are in a standard die. So there would be 3. Okay. There's 6 total numbers, again. And so our probability of an even number is 3 out of 6, or 1/2. So 1/2 of the time, you're going to be rolling an even number. So what we're going to be looking at now is utilizing the items we learned last time in permutations and combinations to kind of find that probability. So we're going to look at the theoretical probability of being dealt exactly 2 7s in a 5-card hand from a standard 52-card deck. Okay? So what we want to do is we're going to kind of clean this up. So we're looking at what is the probability of getting 2 7s in 5 cards. Okay? So we need to kind of find that. So we need to know how many 7s there are in a deck of cards. So there are 4 7s. Okay? And we don't really care which 7s we get. We don't care if we get the 7 of diamonds and the 7 of hearts or the 7 of clubs and the 7 of hearts. It doesn't really matter. So what we're going to be looking at here is we're going to use that combination. And we're looking at 4 choose 2. So this gives me 4 factorial over 2 factorial, 2 factorial. So this is 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. Okay? So this gives me 6 different possible outcomes. And then we're going to look at kind of looking at 3 non-sevens. Okay? And we don't really care about the order there. Well, once I take the 7s out of this deck, I now have 48 cards. And I'm going to choose 3 of them. Now for this one, I'm going to use the calculator. Okay? So I'm going to type in 48 probability. I'm going to go over to NCR and enter, and I'm going to pick 3. And this gives me 17,296 different ways I can get 3 cards. Okay? So now if I want a combination between these two, what I'm going to do is I'm going to multiply these together. So 6 times 17,296. This is a 5-card hand with 2 7s. Okay. So we're going to get that total number. And we get 103,776 different ways that I can get 2 7s and 3 other cards. Now, if I want a 5-card hand, in any order there, I just want to know how many different 5-card hands there are. What I'm going to do is I have 52 cards, and I'm going to choose 5 of them. Okay? So I'm going to look at 52, choose 5. I'm going to use my calculator again, 52, probability, NCR. I'm picking 5 cards. This gives me 259,8960. So 2,598,960. Now to find my probability, 2 7s. I'm going to have the ratio. 103,776 divided by 2,598,960. And I get a probability of 0.0399. So approximately 4% of the time, I'm going to get 2 7s in there. So that's probability. And we're going to talk about 2 more things real quick. One of the things is that this is where simulations come into mathematics. So we're going to use simulations. You can use a random number generator and kind of use that information to kind of find the probability, because since it is random, it is going to be generating those pieces of information. We're not going to spend a lot of time on that. What we're going to be looking at is actually geometric probability. So geometric probability now takes into account area, okay, or volume if it goes that far. Typically, it's an area problem. So we might say, okay, here's our we have our circle inside of a square here. If I know the radius is 5 here, and we'll just say 5 inches. If I want to know the probability of landing inside that shaded area, those corners there, what I'm going to do is I have to find the area of just those corners. And then I have to divide by the total area. So the first thing I want to do is I want to find the area of the square. I want to find the area of the circle. And then I want to find the area of the shaded corners. And then from this point, I will be able to find my probability. So I'm going to start off with the area of the square. So I have a radius of 5 inches. So my whole length on this side now is not 5 inches, but 10 inches. So I have a side length of 10 inches. So my area of my square becomes 100 inches squared. So for my circle, we know that this is actually pi r squared. So pi r squared. So I have pi times 5 squared, which is 25 pi, which when we look at this, we're going to put this in decimal form, 25 pi. So this is going to approximately give me 78.5. We'll round to the nearest decimal, nearest tenth. So the area of the shaded region is now going to be the difference of these. And we get 21.5 inches squared. So now I have my area of my square, my area of my circle, and my area of the shaded region. The only reason I needed my circle was because to find my area of my shaded region. Okay, so I had to find the difference. So my probability of landing in the shaded area is going to be the ratio of my shaded area to my whole, which is my square. So I'd have 21.5 over 100, okay, which is going to give me 0.215 or 21.5%. Okay. So there's my probability. I have 21.5% of the time I'm going to land in that shaded region. That's experimental probability, theoretical probability. I know you guys have done this before. I just wanted to refresh your memories on it.